Hello, this video is for IXL, activity 8.F.5. It is titled Exponents with Decimal and Fractional Bases, and the 3-character code for this activity is 8 Charlie Tango. So how do we handle exponent type terms with fractional bases? What if we have exponents or exponential terms, but the base is a fraction? Because so far we've been working with whole numbers, that's like non-decimal numbers that are positive, and then we started working with integers, which are the opposite of all the whole numbers. They're like non-decimal numbers, but they're negative. So we've been working with whole numbers and we worked with integers. Well, now we're working with fractions and decimals. So we've reached the point of where we have exponents with what is known as rational bases. So how do we handle this? Well, got a couple illustrations here to demonstrate this. So if we have 3/4 to the third power, so we know we need to multiply 3/4 times itself 3 times, right? This is the base. This is the number of times we're going to multiply it. The base is what's getting multiplied, and the exponent tells us how many times to multiply it. So we have 3/4 times 3/4 times 3/4, and then we're going to get an answer. Well, we know that for fractions that we just multiply straight across, numerators times numerators, denominators times denominators, and then we put our answers in the respective spots. Numerator, the product of all the numerators goes in the numerator position, and the product of all the denominators goes in the denominator position. So we had 3/4 times 3/4 times 3/4. We would end up with 3 times 3 times 3, which is 27. And we would also have 4 times 4 times 4, which is 64. And let's look at another way to do that, though. We know that 27 is 3 to the third power. We know that 64 is 4 to the third power. So this kind of lets us know that there's like this little, it's not really a trick, but we can take the exponent 3 in this case and apply it to both the numerator and the denominator, and we can rewrite this instead of 3/4 to the third. We can write this as 3 to the third over 4 to the third. So basically think of it this way: is you're going to take this exponent that's outside the parentheses of the fraction here, and you're going to apply it to both the numerator and the denominator. Now just a quick note here, if we didn't have the parentheses, what if we had 3 over 4 and we just had the exponent 3 there? Well, in this case, it would only apply to the 3, and so we would end up with 27 over 4, because we would not apply it to the 4 because it's not in parentheses. So that's important to note, that you do need the parentheses there. So make sure that if you're working with a situation like this, that indeed that fractional base is inside of a parenthesis. And then you're going to apply that exponent to both the numerator and the denominator. In this case here, we've done that, and then you could go ahead and simplify it. Now we're going to mix that concept along with what we talked about in a previous lesson, is that what if they were negative, right? What if you had a negative exponent? And here we have the negative sign inside the parentheses with the fractional base, and here we have the negative sign outside the parentheses with the fractional base. So if you've done that activity with multiplying negative bases, to where sometimes the negative sign was inside the parentheses with the base, and other times it was outside the parentheses, you probably know this already, that if we have it inside, then it stays with the factors that are being multiplied times each other. So we'd end up with a negative times a negative. That's why we have a positive here. However, if it's outside the parentheses, then we would have the opposite of this base squared. So we would leave that opposite concept there. We go ahead and square that base. We'd have that answer for the base squared, and then the opposite sign would still stay there. And notice that here we've taken the 2 and applied it to the 2 here. 2 squared is 4, and 3 squared is 9. So we just applied this exponent into both the numerator and the denominator, and then simplify it. All right, let's go ahead and take a look at our first one here. So we have 1/2, and it is to the power of 4. So we know we can rewrite this. Let's go ahead and apply the exponent of 4 to both the numerator, and we'll apply it to the denominator as well. Well, 1 to any power is still going to equal 1 because it's just 1 times 1 times 1 times 1, and we still get 1. And then 2 to the 4th. Well, think of it this way, is we kind of think of it as 2 squared times 2 squared, right? Because we know that if we were multiplying these together, we'd still get 2 to the 4th, so it's the same thing. So 2 squared is 4, and the other 2 squared is 4, and then 4 times 4 is 16. So to me, that's a little bit easier than thinking 2 times 2 is 4, times 2 is 8, times 2 is 16. I kind of like to split them up sometimes in my head if it's a little bit easier that way. So that's my approach to it. But 1/16 is the answer. On the next one, we have 2/3. It is inside the parentheses, so we are going to go ahead and apply the exponent of 3 to both the numerator and the denominator. So we're going to have 2 to the 3rd and 3 to the 3rd. Now we could go ahead and simplify this. And 2 to the 3rd is 2 times 2 is 4, times 2 is 8, so that's 2 cubed equals 8. And 3 to the 3rd, well, 3 times 3 is 9. 9 times 3 is 27. So let's go ahead and put in our 8 over 27. That would be our final answer. Moving along, going to have to do a little bit more math on this one, but that's okay. Still the same process, right? And we're going to go ahead and apply this exponent 3 to both the numerator 7 and the denominator 8. So that's going to be 7 to the 3rd, and this is going to be 8 to the 3rd. And so this is going to be what, 7 times 7 times 7 is going to be 21 times 7. And then 7 times 20 is 140, plus the 7 times 1 is 147. Now you can get a calculator out and check that if you'd like. But how I do that in my head is that I think of 20 as 1 as 20 plus 1, and then multiplying them both by 7. And I know that 7 times 2 is 14, and I throw that 0 on there. And then 1 times 7 is 7. Now add those back together to get 147. So that's my mental math that I got going on there. And for the other one, that's 8 times 8 times 8. So 8 times 8 is 64. And then I need to multiply it times 8. And this one here, I could probably mental math that one. Not too bad if I really thought about it, but I think I'm going to go ahead and stack it up instead. And so that's 2, 3, and 8 times 6 is 48. Plus 3 more is 51. So 512. All right. Now, this one's interesting, right? We could just, I already know this is going to be 8 over 9. Because anything raised to the power of 1 is equal to itself. Now, if you wanted to, you could go ahead and write that process out, 8 over 9, put it in its parentheses, and put the exponent there. Now, apply the exponent to both the numerator and to the denominator. Now, let's go ahead and simplify it. Well, 8 to the first power is 8, and 9 to the first power is 9. Now, however, right away, if I saw this here, I probably wouldn't bother with all that because I know anything to the power of 1 is equal to itself. And now we come to decimals. All right, decimals, a little bit different process here, but let's see. We can write decimals as a fraction, correct? We know that the 1 here is in the 10th spot, T-E-N-T-H-S. So since I know that this is in the 10th spot, I know that this value of 0.1 is equal to 1/10. So now, if I rewrite it as a fraction, now I can take that whole decimal, or that whole fraction concept, and I can then go ahead and apply the exponent of 4 to the numerator 1, and also the denominator 10. Now the next step would be to go ahead and do 1 times 1 times 1 times 1, right? 1 to the 4th is going to be 1. Now 10 to the 4th, hopefully by now you've realized that there's a little shortcut for there. It's a 1 with 4 zeros, 1, 2, 3, and 4, right? So 1/10,000th. Now if I start talking about decimal places here, right? Here is the, and I'm going to use numbers, tenths place. The next decimal is the hundredths place, THS. And the next decimal, see if I can squeeze it up. I'm going to write it over at the top so I don't get too far out, is the 1,000ths place, THS, and then the next decimal spot is the 10,000ths place. And we're finally to the point that we have 1/10,000th. So we put a 1 there, put placeholding zeros in here. So we would see that our answer is 0.0001. So I'm going to go ahead and write that in there, 0.0001. Now, there's another shortcut that we can kind of consider. There seems to be something going on. Let's look and see what that is. If I took 1 to the power of 4, I would just get 1. And I have one decimal place here, right? So think of this, put a 1 over there. I've got one decimal place. Now if I multiply the number of decimal places times the exponent, that'll tell me how many decimal places I need. Well, 1 times 4 equals 4, so I should have 4 decimal places. And sure enough, I do. 1, 2, 3, 4 decimal places. We'll see if that holds true. Let's try it out on the next problem here. So I have 3/10 or 0.3 squared. Now I'm going to go ahead and treat this one differently. I don't want to go ahead and set it up as a fraction because I know I'm going to end up with a number that's not going to be so easy to do like that. So instead I'm going to go ahead and set it up as 0.3 times 0.3. Well, 3 times 3 is 9. And here I have 1 decimal place, and here I have 1 decimal place. So if you understand the algorithm of multiplying decimal numbers, you kind of got an idea what's going on here. So 1 decimal place in the first factor, 1 decimal place in the second factor. 1 plus 1 is 2, so I should have 2 decimal places. So I'm going to need a 0 in front of this and put a 0 there, so 0.09. Now I have 1 decimal place, right? My exponent is 2. 1 times 2 equals 2. So I should have 2 decimal places. So 3 squared is 9, and my answer should have 2 decimal places. On the next one here, and did I do, oh, this is 3 to the third. Okay, so let's try that out here. So let's do see if we can take that shortcut, right? So let's just treat this as 3 cubed. And that is 27. And I have 1 decimal place. 3 is the exponent. 1 times 3 equals 3. So I should have 3 decimal places. So I'm going to put 27. I need a 0 so I can have 3 decimal places. And it should be 0.027. So I'm going to go ahead and check it on my calculator. So if I have 0.3 and I raise that to the power of 3, sure enough, I get 0. Can you see it there? I don't know if it'll focus. There we go. Yep. Sure enough, it is 0.27. So it seems to be that little trick works out. So let's try it on the next one. On this one here, I have 2 decimal places. I'm going to figure out my decimal places first. So I have 2 decimal places multiplying it times the exponent. 2 times 4 is 8. So seems like a lot. I should have 8 decimal places. Now, 3 to the 4th, right? 3 to the power of 4. So that is 3 times 3 times 3 times 3. Well, 3 times 3 is 9. 3 times 3 is 9. Now multiply those two 9s together, and I get 81. So 81 is my answer, and I need 8 decimal places. So I've got 2 of them already. So I need, 6 zeros? 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6, 7, 8. Okay, that should be it there. So I'm going to go ahead and test that on my calculator. 0.03 raised to the power of 4. And sure enough, I get 8.1 and e minus 7. So that means move the decimal place over 7 places, and then I would have the same thing. So that's what it looks like here for calculator notation. If you get something like that, 8.1 e minus 7, well, the negative 7 says move the decimal over 7 places to the left, making the number smaller. And at that point, I would then have 6 zeros in front of the 8 and the 1. So that worked out all right for me. Camera coming back in. There we go. And let's continue trying that strategy. We have 2 decimal places here, and 2 times the exponent 2 equals 4. And now let's deal with the 2 squared. So 2 squared is 4. So I want a 4. And I had 2 decimal places. The exponent's 2. 2 times 2 is 4. So I need 4 decimal places. So that means I need 3 zeros in front of it. Now I have a 4, and it's in the 4th position after the decimal. On this one here, I have 2 decimal places. 4 is the exponent, so 2 times 4 equals 8. And now 3 to the 4th. Well, 3 to the 4th we did just a little bit ago, didn't we? 3 to the 4th, we know that's 81. So that's going to equal 81. So we're going to put in 81. And I need 8 decimal places. Did I do this same problem twice? 1, 2, 3, 4, 5. I think 6 is it. 1, 2, 3, 4, 5, 6, 7, 8. Yep, decimal 0. Did I do that same problem twice? And surely I did. I posted the same problem twice. We did the same one twice. And then my last 2, these should be pretty simple for you because they're to the power of 0. And if we learned anything so far in our other lessons, we learned that anything to the power of 0 equals, that's right, 1. So anything to the power of 0 equals 1. So the last 2, both these examples are to the power of 0. So our answer is going to be 1. And concludes all of my examples for IXL 8.F.5, exponents with decimal and fractional bases. And good luck with your activity.